Each alphabet MOS in most capacitor means metal, oxide, and semiconductor. So Moscap means capacitor made of metal, oxide, and semiconductor. As the metal part, we usually use metal or the heavily doped semiconductor, and we call this part gate. For the oxide part, we usually use silicon dioxide, and we call this part gate dielectric. For the semiconductor part, we use N-type semiconductor or P-type semiconductor, and we call this part body. These two different energy band is about the most capacitors energy band, which use P-type semiconductor or the N-type semiconductor. Same as PN junction diode and Schottky diode, to express the thermal equilibrium condition, we should draw the metal's work function and the Fermi level constant. Because of the characteristic of metal which called equipotential, we should always draw the metal's work function constant. So at the junction of each materials, only for the oxide and semiconductor will be banded to keep the material's property such as electroaffinity or ionization energy. To control this energy band, we should make bias at the edge of energy band. Suppose that we use the N-type semiconductor for the gate body, and if we make negative bias to the gate part and the positive bias to the edge of body part, then the work function of metal is gonna be higher than before, and the energy band of the semiconductor will be lower than before. So the major mobile carrier hole will be accumulated at the interface of gate dielectric and body. We call this phenomenon accumulation. Oppositely, if we make positive bias at the edge of gate and the negative bias at the edge of body, then the metal's work function will be lower than before, and the energy band of semiconductor will be higher than before. So the mobile carrier hole's concentration at the interface of gate dielectric and body will be tiny. If we make a huge positive bias at the edge of gate part, then the electrons in the body part will be attracted by the positive bias. So it accumulates at the surface between the gate dielectric and body part. Actually, the body part's majority mobile carrier was hole originally, but now the majority carrier at the surface will be changed into the electron, and these mobile carrier will make a channel that we can the current will be flow easily at this part. We call this phenomenon inversion, and to make this condition, we should make a bias bigger than the threshold voltage. Threshold voltage generates when the potential difference of the conduction band and Fermi level at the surface equals to the potential difference between Fermi level and the valence band at the body part.